Hey guys, welcome to this slide. We're kicking off our AZ-204 preparation guide with the basics, an introduction to the AZ-204 exam. If you're watching this, you're probably thinking about becoming a Microsoft Certified Azure Developer Associate, and let me tell you, it's an awesome certification to have. It really proves you know how to build real-world cloud solutions on Azure. So what is AZ-204 all about? It's officially called Developing Solutions for Microsoft Azure, and it's designed for developers who want to show they can design, build, test, and maintain cloud applications and services on Azure. You need some experience, ideally 1 to 2 years working with Azure, and you should be comfortable with at least one programming language like C#, Python, JavaScript, or Java. Don't worry if you're not an expert yet. This exam is practical, not just theory. You've got 100 minutes to answer 40 to 60 questions. These can be multiple choice, case studies where you read a business scenario and pick the best solution, drag and drop for ordering steps, or even hot areas where you click on parts of a diagram. Passing score is 700 out of 1,000, which sounds scary, but it's achievable with good prep. No negative marking, so always guess if you're running out of time. The exam covers 5 main areas, and we'll dive deep into them later, but quickly. About 25 to 30% on compute solutions like app services and functions, 15 to 20% on storage, same for security, 10 to 15% on monitoring and troubleshooting, and 20 to 25% on connecting to services. Right now, as of December 2025, these weights are current, but heads up. The English version gets an update on January 14, 2026, so if you're taking it after that, check the latest study guide on Microsoft Learn. Why go for this cert? It opens doors, better jobs, higher pay, and it's valid for 2 years before you need to renew with a free assessment. Plus, employers love it because it shows you're hands-on with Azure. My advice to start: go to Microsoft Learn and take their free skills assessment for AZ-204. It'll tell you exactly where your gaps are. If you're new to Azure, knock out AZ-900 fundamentals first. It's a great foundation. All right, that's the intro. Let's move to the next slide where we break down the exam structure in more detail. Okay, let's dig a bit deeper into the exam overview and structure. Understanding how the test is built will help you strategize your time and study focus. First, the skills breakdown with those weights I mentioned. Develop Azure Compute Solutions is the heaviest at 25, 30, 30%. That's where most questions come from. Then connecting to and consuming services at 20 to 25%, storage and security both 15 to 20%, and monitoring troubleshooting at 10 to 15%. These percentages guide your study time. Spend more on compute if you want to maximize points. Question types? Mostly multiple choice or select the best answer, but case studies are big. They give you a company scenario, like a retail app needing scalability, and then 4 to 6 questions based on it. Drag and drop for things like deployment steps or build lists for configuring something. Sometimes labs, but for AZ-204, it's more scenario-based than hands-on typing. Time management. 100 minutes for 40 to 60 questions means about 1.5 to 2 minutes per question. Read carefully. Questions often have distractors that sound right but miss a key detail. Flag tough ones and come back. The exam is proctored online or in person via Pearson VUE. Cost is usually around 165 USD, but check for discounts. It's available in multiple languages, but English updates January 2026. Prerequisites? Officially none, but AZ-900 helps a ton, and you need dev experience. No Azure Portal, CLI, PowerShell. Questions assume you're comfortable navigating. Certification lasts 2 years. Renew free online. If you fail, wait 24 hours for retry, longer after multiple. Pro tips: use Azure free tier for practice. $200 credit, no cost surprises if you clean up resources. Exam has no penalties for wrong answers, so never leave blank. This structure is scenario heavy because real dev work is about choosing the right tool. Think, what would I do in this situation? Now we'll talk prep strategies. All right, preparation strategies for AZ-204. This is where most people win or lose the exam. Smart studying beats cramming every time. First, make a realistic study plan. If you're working full-time, aim for 6 to 8 weeks, 10 to 15 hours a week. Allocate time by weights. 30% on compute, 25% on integration, etc. Start with your weak areas from the skills assessment. The best free resource? Microsoft Learn. Their AZ-204 path has modules with reading, videos, and sandbox labs. No subscription needed for basics. Complete every lab, that's where knowledge sticks. Hands-on is non-negotiable. Get an Azure subscription, free tier is perfect. Recreate everything. Deploy apps, configure storage, set up auth, delete stuff after to save money. Practice tests. Microsoft's official ones are gold, but also try third-party like MeasureUp. Do full-timed mocks. Simulate exam day. Review wrong answers deeply. Communities are lifesavers. Azure on Reddit, Microsoft forums, LinkedIn groups. Ask questions, see what others struggled with. Documentation. Bookmark Azure Docs. No SDKs for .NET, Python, REST APIs, CLI commands. Track progress weekly. Quiz yourself, note improvements. If security feels fuzzy, double down there. Exam day. Sleep well, eat, read questions twice. Manage time, don't get stuck. Bonus, build projects like a full app with functions, Cosmos, Entra ID. It ties everything together. This strategy works because the exam is practical. You're ready when you can explain why you choose functions over app service. Welcome to the biggest section, Develop Azure Compute Solutions, 25 to 30% of the exam. This is core Azure dev stuff, running your code scalably without servers. Why so heavy? Compute is where apps live. Web apps, serverless, containers. Subtopics, containerized solutions and app service functions. Containers for consistency, same in dev and prod. App service for PaaS web hosting. Functions for event-driven serverless measures. Real world, microservices often use containers. E-commerce sites use app service. Background processing functions, prep tip. Hands-on everything. Deploy samples via portal, CLI, ARM. Common mistakes, ignoring cost scaling, poor security in images. Resources, Microsoft Learn, implement Azure Compute Solutions modules, labs galore. Exam questions, scenarios like high traffic app, cost-effective scale. Think auto-scaling. This section rewards practice. Know when to use each. Next slides dive deeper. Containers first. Let's talk implement containerized solutions. Containers are huge in modern dev. Why? Portability, isolation, efficiency. Start with images. Dockerfile defines your app dependencies. Build locally with Docker, Azure Container Registry, ACR, private repo. Push images, geo-replicate, scan vulnerabilities. Exam loves this. Azure Container Instances, ACI. Quick deploy, no orchestration. Great for jobs. Container apps, managed, auto-scale with Kita, revision management. Security, RBAC, private endpoints, image scanning, scaling, CPU memory rules, environment vars, hands-on. Containerize a .NET app, push ACR, deploy ACI container apps. CLI, AZ Acre build, AZ container create, build a .NET app, containerize it, push to ACR, and deploy to ACI, test with sample traffic. No differences, ACI simple, container apps advanced. This is foundational for microservices. Azure App Service Web Apps is basically Microsoft's platform as a service offering for hosting web applications. You don't have to worry about servers, patches, or operating systems. You just deploy your code and Azure runs it. It supports .NET, .NET Core, Java, Ruby, Node.js, PHP, Python, pretty much anything you'd use for a web app. Super versatile, right? First thing you need to know, how to create one. In the portal, it's literally a few clicks. Search for app service, hit create, pick your subscription, resource group, give it a name that becomes part of the URL tree like myapp.azurewebsites.net. Choose your runtime stack, region, and pricing tier. Exam loves asking which tier supports custom domains or auto-scaling. Remember, free and shared are for dev test, basic and above for production stuff like SSL and scaling. Once it's created, deployment is next. You've got so many options, and trust me, the exam will throw scenarios at you to pick the best one. You can deploy straight from GitHub, GitLab, Bitbucket with continuous deployment. Super smooth, every push triggers a build and deploy, or use local Git, zip deploy, FTP if you're old school, or even Visual Studio VS Code direct publish. And here's a big one. App Service supports Docker containers too. So if your app is containerized, you can point it to ACR or Docker Hub and run it as a web app. That flexibility is gold in real projects. Now, let's talk diagnostics and logging. This is huge for troubleshooting. Out of the box, App Service gives you application logs, web server logs, failed request tracing, but the real MVP is integrating with application insights. One toggle and boom, you get performance metrics, request tracing, exceptions, dependency calls, all in one place. The exam loves questions like, how do you monitor slow database calls, application insights, hands down. Also, enable diagnostic settings to stream logs to log analytics or storage for longer retention. Configuration settings. Don't skip this. You've got application settings like connection strings, API keys, which are encrypted at rest and injected as environment variables. Connection strings have their own section for databases. Then there's TLS SSL. App Service gives you a free managed certificate for the Azure websites.domain, and you can upload your own or buy through Azure. Force HTTPS, just one toggle. Custom domains, add them. Validate ownership, point CNAME or A record. Exam scenario classic. Company requires HTTPS and custom domain. Bind custom domain, enable HTTPS only. Autoscaling. This is where App Service shines for production apps. You can scale out, add instances, or scale up, bigger VMs. Rules-based scaling is the most common. Scale out when CPU 70% for 10 minutes. Scale in when 30%. You can also schedule scaling for predictable traffic, like more instances during business hours. Premium tiers give you more granularity. Think about it. Black Friday traffic spike, autoscaling saves you from crashes and overpaying. And deployment slots. Oh man, this feature is a lifesaver and exam favorite. You can create staging, dev, test slots. Deploy new version to staging, warm it up, traffic goes there to initialize, run smoke tests, then swap with production. Zero downtime. You can even route percentage of traffic to staging for A/B testing. Swap warms up the new version automatically. If something breaks, swap back instantly. Every production deployment should use slots. It's best practice. Quick hands-on tip. Go create a simple .NET or Node app, deploy to App Service, set up a staging slot, push a change, like change background color, swap, and watch it go live without a blip. Do that once, and you'll never forget how powerful it is. Common pitfalls? Forgetting to set website run from package for zip deploy performance, or leaving debug mode on in production. Also, remember managed identities. Your web app can authenticate to Key Vault, SQL, without secrets in code. If App Service is your go-to for traditional web apps, Azure Functions is where the serverless magic happens. This is event-driven, pay-per-execution computing, and it's a huge chunk of the compute solutions section. So let's make sure you own this topic. Okay, picture this. You've got tasks in your app that don't need a full web server running 24/7, like processing an image when it's uploaded, sending a welcome email when someone signs up, or running a nightly report. That's where functions shine. You write a small piece of code, Azure runs it only when triggered, and you pay literally for the milliseconds it executes. No idle servers, no over-provisioning, super cost-effective. First things first, creating and configuring an Azure Functions app. In the portal, search for Function App, hit Create, pick your runtime. Net 8 is isolated and awesome, but you've also got Node.js, Python, Java, PowerShell. Choose consumption plan for true serverless, pay per execution, premium for always warm instances and VNet integration, or app service plan if you want to reuse existing capacity. Most exam questions go with consumption because it's the default serverless experience. You'll also need a storage account. Functions uses it for state, triggers, and logs. Pick general purpose v2 in the same region for lower latency. Now, the heart of functions, triggers and bindings. This is what makes functions so powerful and what the exam tests heavily. Triggers are how your function starts. HTTP for APIs, webhooks, timer for scheduled jobs, cron syntax, baby, blob for when a file lands in storage, queue for background processing, event grid for reacting to Azure events, Cosmos DB change feed for real-time syncs, service bus, event hubs, the list is long. Bindings are the no boilerplate way to read-write data. Input bindings pull data in, like read a blob. Output bindings push data out, write to Cosmos or send to a queue. You declare them in function.json or with attributes in code, and Azure handles the connections. For example, a blob trigger with a blob output binding resizes an uploaded image and saves the thumbnail, all with maybe 20 lines of code. Let's talk scaling. In consumption plan, Azure auto-scales instantly, thousands of instances if needed. Cold starts can happen, first request after idle, but premium plan pre-warms instances to avoid that. Durable functions, game changer for orchestration. Think stateful workflows like approval processes or long-running aggregations. You get fan out, fan in, human interaction, timers, all while staying serverless. Best practices the exam loves. Handle retries, especially for queues. Make functions idempotent, safe to run twice. Monitor with application insights built in. and use managed identities for secure access to other services. No secrets in code. Hands-on tip, build this classic scenario, HTTP triggered function that accepts an image URL, downloads it, resizes with a library, saves thumbnail to Blob Storage using output binding. Then add a timer trigger that cleans up old files. Do that once in the portal or VS Code with the Azure Functions extension and you'll feel unstoppable. Common pitfalls? Forgetting to set the storage connection string correctly, or choosing the wrong runtime version, use isolated for .NET 8. Also, watch execution time. Default timeout is 5 minutes in consumption, configurable to 10 max. Unlike traditional SQL databases, Azure Storage here focuses on non-relational options, mainly Azure Cosmos DB for globally distributed, multi-model NoSQL goodness, and Azure Blob Storage for massive unstructured data like images, videos, logs, backups, you name it. The exam wants you to know when to pick one over the other and how to code against them using the SDKs. Why non-relational? Modern apps deal with huge scale, flexible schemas, and global users. Cosmos DB handles that with low latency worldwide, while blobs are perfect for cheap, durable object storage. Think e-commerce product images in blobs or user profiles in Cosmos for a social app. Key skills the exam tests: performing operations with the SDKs, like CRUD on containers and items in Cosmos, or uploading/downloading blobs. Setting consistency levels in Cosmos, we'll dive deep in the next slide, implementing change feeds for real-time updates, and for blobs, managing properties, metadata, lifecycle policies to auto-tier or delete old data, and storage policies for cost savings. Preparation tip: this is all about the code. You need to be comfortable with the Azure SDKs, usually .NET or Python examples on the exam, but concepts are the same. Know how to handle partitioning in Cosmos for scale and throughput with request units, RUs. Common scenarios you'll see. Your app needs to store terabytes of logs cheaply and archive old ones. Blobs with lifecycle management, or global app with strong consistency for financial data but low latency. Cosmos with tunable consistency. Hands-on is key here. Create a storage account, upload some blobs via portal and code, set a lifecycle policy to move to cool after 30 days. Spin up a Cosmos account, free tier has it, and play with the SQL API. Pitfalls to avoid: forgetting that Cosmos is multi-model, SQL, Mongo, Cassandra APIs, etc., but exam focuses on core SQL API. Or ignoring data lifecycle in blobs, costs add up fast if you leave everything in hot tier. Resources: hit up the Microsoft Learn path called Develop for Azure Storage. It's got labs for SDK operations, change feeds, everything. As of right now, in December 2025, this is still the current blueprint, but heads up, the English exam updates January 14th, 2026, so check the study guide for any tweaks. Exam loves comparing use cases. Cosmos for low latency queries on JSON docs, blobs for simple file storage. No partitioning strategies, bad partition key kills performance. And cost stuff. Hot, cool archive tiers, RU provisioning versus serverless. This is the deep dive into Cosmos DB, the star of the storage section for non-relational, globally distributed data. If you nailed the overview last time, you're ready for this. Cosmos is a big favorite on the exam because it's so powerful for modern apps, and questions here can make or break that 15 to 20% storage weight. All right, let's break it down conversationally. Azure Cosmos DB is Microsoft's fully managed planet-scale NoSQL database. It's multi-model, meaning it supports key-value, document, SQL APIs, the exam focus, graph, columnar, and even MongoDB Cassandra APIs. But for AZ-204, we're all about the core NoSQL API with SQLite queries on JSON documents. Why do devs love it? Insane low latency anywhere in the world, automatic scaling, and 5 consistency levels to balance speed versus accuracy. First big thing, SDK operations. You need to know how to perform CRUD on containers and items using the SDK, mostly .NET or Python examples on the exam. In code, you create a Cosmos client, then get or create database, container, and do create item async, read item async, upsert, super handy for insert or update, query items with SQL strings like select char from C, where c.status equals active. Partition keys are crucial here. Choose a high cardinality property like user ID so data spreads evenly and queries are fast. Bad partition? Cross-partition queries eat RUs and slow everything down. Speaking of consistency levels, this is exam gold. You've got 5. Strong linearizability, slowest but safest for finance, bounded staleness, stale by time regions, session. perfect for user sessions, consistent for one user, consistent prefix, never out of order writes, and eventual, fastest, great for social feeds. The exam will throw scenarios. Global app needs reads eventually consistent to save cost, pick eventual, or banking transfers, strong. Default is session, know why it's the sweet spot for most apps. Then change feed notifications. Oh man, this is awesome for real time. Change feed is like a log of all inserts, updates, deletes in order. Pull model, you pull it yourself, store continuation token. Push model, recommended, use change feed processor with a lease container. It handles state, parallelism, even delegates to functions or app services. Classic scenario, sync data to cache, trigger notifications, or build materialized views. Hands-on, set up a function with Cosmos trigger on change feed, watch it fire instantly. Other must-knows, partitioning, logical partitions inside physical, synthetic keys if needed. Indexing, default indexes everything, but customize to exclude paths and save RUs. Global distribution, add regions, set multi-region rights for active-active. Security, keys, RBAC, private endpoints. Hands-on tip, spin up a free tier Cosmos account, use the .NET SDK in a console app, insert items, query across partitions, enable change feed, and hook a function to it. Also play with consistency in the portal, switch levels and see latency RU changes. Common pitfalls, forgetting partition key in queries, fan out, expensive, or picking strong consistency when not needed hurts performance. Exam loves optimize RU consumption or real-time updates. Change feed. If Cosmos DB was the fancy, globally distributed NoSQL champ we talked about last time, Blob Storage is the workhorse for all your unstructured data needs. This is super practical. Think images, videos, logs, backups, documents, anything that's not structured like a table. It's a big part of that 15 to 20% storage weight on the AZ-204 exam, so let's make sure you're comfortable coding against it. Okay, let's start with the basics. Azure Blob Storage lives inside a storage account. General purpose V2 is what you'll use most. You've got three types of blobs. Block blobs for most stuff like files up to 5 terabytes. Append blobs, perfect for logging. You just keep adding to the end. And page blobs for VHDs or random access. Exam usually focuses on block and append. Now, properties and metadata. This is key for the exam. Properties are system stuff like content type, length, last modified. Metadata is your custom key value pairs. Great for tagging blobs like department marketing or environment prod. You set them on upload or later and query filter with them. In code, it's super easy with the SDK. Speaking of SDK operations, this is where you spend most time practicing. Use the Azure Storage Client Library. Version 12 for .NET is the modern one with async everything. Get a blob service client from connection string or managed identity, then container client, then blob client. Upload with upload async for small or block uploads for big files parallel. Download, list blobs with prefixes for virtual folders, delete, lease for concurrency. Exam scenarios, large video upload efficiently, use block upload with staging and commit. Or list all images in a folder, prefix and list blobs by hierarchy. Storage policies and data lifecycle management, huge for cost optimization, and the exam loves this. Access tiers, hot for frequent access, cool for infrequent, cheaper storage, higher retrieval. Archive for long-term, cheapest, but rehydrate to access. Set on upload or change later. Lifecycle management policies. Rules like if blob older than 90 days and last accessed 30 days, move to cool. After 365 days, delete, or tier to archive. Automates everything, saves money, big time. There's also versioning, enable it, every overwrite creates a version, recover from mistakes. Soft delete for accidental deletes, retain for days, and restore. Shared access signatures, SaaS, secure delegated access without keys. Generate account SaaS or service user delegation, better, uses Entra ID. Set permissions, read, write, expiry, IP restrictions. Classic, secure public URL for download with time limit. Integration tip, trigger functions on blob upload for processing or use AsCopy Storage Explorer for bulk, hands-on. Create storage account, container, upload blob with metadata via .NET SDK, set lifecycle policy to archive old blobs, generate SaaS URL. Test versioning by overwriting and rolling back. Pitfalls, forgetting hierarchical namespace for ADLS features or high costs from wrong tier. Exam, minimize costs for infrequently accessed logs, cool tier plus lifecycle. As of right now, December 19th, 2025, this is current. English exam updates January 14, 2026, so quick check the study guide after if testing then. Blob Storage is straightforward but powerful. Master it. Easy points. This section carries about 15 to 20% of the exam weight, but honestly, security concepts show up across almost every topic: compute, storage, functions, APIs, you name it. If you get security wrong, it can cost you big points, because real-world Azure development isn't just about making things work, it's about making them work securely. Nobody wants their app hacked because of a silly mistake, right? Let's talk about what this section really focuses on. It's broken into two main parts: implementing user authentication and authorization, and implementing secure Azure solutions. The first part is all about identity. Who's logging in, how do we verify them, and what can they do once they're in? The second is about protecting your app's sensitive data, like secrets, keys, and configs, without exposing them in code or configs. At the center of pretty much everything is Microsoft Entra ID. Yeah, it's the new name for Azure AD. Get used to saying Entra ID now. This is where you handle authenticating users with Microsoft accounts, work accounts, or even social logins, and authorizing them with roles, scopes, and claims. The exam loves scenarios like, your app needs single sign-on for enterprise users, Entra ID app registration with MSAL library. Then we've got shared access signatures, SAS, for securely sharing access to storage without giving away account keys, super common for blobs or queues. On the secure solutions side, Azure Key Vault is your best friend for storing secrets, keys, and certificates. No more hard-coding connection strings, reference them, or fetch at runtime. Azure App Configuration for feature flags and non-secret settings with built-in encryption and access controls. And the game changer, managed identities. Your app service, function, or VM can authenticate to other Azure resources automatically. No credentials and code, no rotation headaches. System assigned or user assigned, no both. Finally, Microsoft Graph, securely querying user data, calendars, mail, etc., with permissions, delegated or application. Why does the exam hammer this? Because developers own security now. DevSecOps style. Questions often come in case studies. How do you securely connect a function to Cosmos DB? Managed identity, or allow temporary read access to a blob, SAS token. Prep tips, hands-on, hands-on, hands-on. Register an app in Entra ID portal, implement login in a sample app with MSAL, create a key vault, grant access via RBAC, and have your web app pull a secret using managed identity. Do that flow once, and it all clicks. Common mistakes? Using storage account keys instead of identities/SAS, over-permissive roles, or forgetting to enable HTTPS TLS everywhere. Quick note on the exam itself. As of today, December 19th, 2025, this content is fully current. The English version is set to update on January 14th, 2026. So if you're taking it after that, definitely review the latest study guide on Microsoft Learn for any tweaks. Implement user authentication and authorization. This is a huge part of the 15 to 20% security weight on the AZ-204 exam, probably one of the most tested areas because every app needs to know who is using it and what they can do. Get this right, and you're grabbing solid points in case studies and multiple choice questions alike. Let's break it down like we're building a real app together. The core here is Microsoft Entra ID. That's the modern name for what used to be Azure AD. It's Microsoft's cloud identity platform, handling both authentication, proving who you are, and authorization, what you're allowed to do. First step, register your app in Entra ID. Go to the portal, App Registrations, New Registration, give it a name, choose supported account types, single tenant for internal apps, multi-tenant for SaaS, or personal Microsoft accounts for consumer stuff. Set redirect URIs, super important, where tokens come back after login. Exam loves asking why login fails. Wrong redirect URI is a classic. Once registered, you get client ID, tenant ID. For web apps, add a secret or certificate for confidential client flows. Then expose API scopes or use app roles for authorization. Now, implementing authentication, use the Microsoft Authentication Library, MSAL. It's available for .NET, JavaScript, Python, Java. Pick your poison. For a web app, msal.net handles sign-in token acquisition. You can do authorization code flow for interactive login, user signs in with work, school, or personal account, gets redirected back with code, exchange for token. Tokens are JWE's ID token for auth, who the user is, claims like email, name, access token for calling APIs with scopes like user.read. Validate tokens properly. Check issuer, audience, signature. For authorization, use roles or groups in Entra ID. Assign users to app roles you define or use group claims. In code, check claims with authorize roles equal admin in ASP.NET or manually in functions. Conditional access policies can block risky sign-ins. Know they impact your app. Multi-tenant apps set to accounts in any org handle tenant-specific logic. Consent. Admin consent for app permissions. Then shared access signatures, SAS. Not Entra ID, but big here for storage. Generate SAS for blobs, queues, etc. User delegation. Best uses Entra ID, service, or account level. Set start, expiry, permissions, read-write, IP restrictions. Perfect for temporary access like signed URL for download. Register app, add delegated on behalf of user or application permissions. Use msal to get token with scope, https:/graph.microsoft.com/default. Then call Graph SDK for users, groups, mail, etc. Hands-on tip. Build a simple ASP.NET app, register an Entra ID, add msal for login, protect a controller with roles, generate SAS for a blob, upload, download. Test multi-tenant if you can. Common pitfalls. Wrong token audience, forgetting to request offline access for refresh tokens, or using account SAS when user delegation is better. This is the other half of the 15 to 20% security section on the AZ-204 exam, focusing on protecting your app's configuration data and writing code that handles sensitive stuff securely. If you nailed user auth last time with Entra ID and SAS, this builds on it perfectly. Let's chat about why this matters and how to own it. First off, the big idea. Never hardcode secrets, keys, or certificates in your code or config files. That's a massive security risk. Think Git commits exposing database passwords. Instead, Azure gives you tools to store and access them securely at runtime. The star here is Azure Key Vault. It's a centralized, encrypted store for secrets like API keys, connection strings, keys, crypto keys, and certificates, SSL certs. You create a key vault, add your secrets, super easy in the portal or CLI. Then in your app, you reference them or fetch dynamically. How do apps access it? Two main ways. One, reference in app service or functions. In application settings, use at Microsoft.KeyVault secret URI equal to syntax. Azure pulls the value at startup, injects as nvar, no code change needed, perfect for connection strings. Two, in code with SDK, use the KeyVault SDK, secret client in .NET. But how do you authenticate without another secret? Enter managed identities. This is exam gold. Your app service, function, VM, etc. gets an identity in Entra ID. System assigned, tied to resource lifecycle, or user assigned, reusable. Enable it, grant RBAC like Key Vault secrets user on the vault, boom, your code auths passwordless with default Azure credential. No keys rotating manually. Then Azure app configuration, great for non-secrets like feature flags, app settings. Pull configs dynamically, supports versioning, labeling, dev prod. Integrate with Key Vault references for secrets inside configs. Feature management library makes toggling features easy without redeploys. Developing code that uses keys, secrets, certs in .NET, use secret client.getSecret async or certificate client for certs. Always handle exceptions, cache values briefly if needed. For crypto, use managed keys in Key Vault for sign encrypt without exposing private keys. Other bits. Encryption, data at rest, automatic in most services, in transit HTTPS. Auditing, enable diagnostics on Key Vault to log access, hands-on tip. Create a Key Vault, add a secret. Spin up a function app with system managed identity, grant access, write a function that fetches the secret and logs it safely. Then reference it in app settings. Do that and you'll ace scenarios like securely stored DB password for web app. Common pitfalls? Forgetting to purge deleted secrets, soft delete enabled by default, or using access keys instead of identities. Exam loves no secrets in code, managed identities. Monitor and troubleshoot Azure solutions. Okay, I know what you're thinking. This section is only 10 to 15% of the AZ-204 exam, the lightest weight out of all 5 areas. But don't skip it. Monitoring and troubleshooting questions sneak into case studies across the board, and in real dev life, this is where you spend half your time fixing stuff that breaks in production. Plus, good monitoring helps you optimize costs and performance. Total win. So, what's this all about? It's centered on application insights, Azure's powerhouse for application performance management, APM. App Insights collects telemetry from your apps, whether they're web apps, functions, containers, or even on-prem, and gives you a single pane to see what's going on. Key things the exam tests. Monitor and analyze metrics, logs, and traces. Metrics are numeric, like CPU usage, request counts, response times. Logs are your console.log or trace statements. Traces are end-to-end request flows, showing how a call bounces through services. You query all this with Kusto query language, KQL, and log analytics, super powerful like SQL but for logs. Then implement application insights, web tests, and alerts. Web tests, that's availability monitoring. Ping your endpoints from locations worldwide, check response time, or even multi-step like login flows. If it fails, boom, alert. Alerts can notify via email, SMS, webhook, or trigger actions like scaling or logic apps. Instrument an app or service. This means adding the App Insights SDK or enabling agent-based no-code for .NET in app service/functions. Track custom events, exceptions, dependencies like DB calls. Encode telemetry client.track event, track exception, etc. For functions or containers, configure with connection string or managed identity. Troubleshooting flow, something slow, go to Performance Blade, see Slowest Operations. Errors spiking, Failures tab. User complaining, search by session ID. Live metrics is awesome for real-time, no delay, watch requests stream in during deploy. Optimization tie-in. Use insights to spot bottlenecks, like slow SQL queries, and fix them, or identify underused resources to downscale and save money. Hands-on tip. Take any sample app, deploy to app service, enable App Insights one click, throw some traffic, use load test or just browse, then explore the portal. Set up a web test for your root URL, create an alert for 500 errors. Query logs, requests, where timestamp, AGO1H, summarize count by client score city. You'll feel like a detective. Common pitfalls? Forgetting to set the instrumentation key or use app settings, or thinking App Insights only works for .NET. It supports all major languages. Also, data retention. Free 90 days, but query older if needed. Connect to and consume Azure services and third-party services. This is the Connect to and consume Azure services and third-party services area, weighing in at a solid 20 to 25% of the AZ-204 exam. That's a lot of points on the line, and it's all about integration, how your apps talk to APIs, handle events, and process messages reliably. This is where your solutions feel truly cloud-native and decoupled, right? Let's break it down. The section splits into three main parts: API management for exposing and securing your APIs, event-based solutions with Event Grid and Event Hubs, and message-based solutions with Service Bus and Queue Storage. The exam wants you to know when to use which events for reactive, lightweight notifications, messages for guaranteed delivery and ordering. Starting with Azure API Management, APIM, think of it as the front door for your backend services. You create an APIM instance, import your APIs from OpenAPI Swagger specs, functions, app service, whatever, and then add policies, rate limiting, quota, JWT validation, IP filtering, even request response transformations. Document them in the developer portal for self-service. Secure with subscriptions keys or Ultra ID. Exam classic, expose functions securely with throttling, APM policies all the way. Then event-based solutions. Event Grid is reactive pub sub, super fast, low cost, sources like blob creation, resource group changes, or custom topics. Subscribers, functions, logic apps, webhooks, domains for multi-tenant, no routing, retry policies, dead letter and hubs for massive ingestion. Think IoT telemetry, logs streaming, namespaces, hubs, capture to storage, partition for parallelism. Process with stream analytics or functions, key difference. Grid for discrete events, something happened. Hubs for high throughput streams. Now message-based, service bus for enterprise messaging, queues for point-to-point, topics, subscriptions for pub sub, sessions for ordering, duplicate detection, dead letter queues, transactions, premium for geo-replication. Queue storage, simple, cheap FIFO queues and storage accounts. Great for basic decoupling like background jobs, when to choose. Need ordered exactly once, sessions. Service bus, just fire and forget, cheap queue, queue storage. High volume streams, event hubs. Reactive notifications, Event Grid.exam loves integration patterns. App needs to react to blob upload, Event Grid trigger function. Reliable order processing, service bus queue with peak lock. Hands-on tip, build a system, upload file to blob, Event Grid triggers function, processes and sends to service bus topic, another function consumes and saves to Cosmos. Add APIM in front of a HTTP function. That's end-to-end gold. Best practices, idempotency, safe retries, poisoning handling, scaling consumers. Implement API management and event message solutions. the hands-on deep dive into that 20 to 25% integration section we overviewed last time. This is where your apps stop being isolated and start talking to each other reliably, scalably, and securely. If you've ever built a system where one service notifies another or exposes APIs to the world, this is the stuff that makes it production ready. Let's jump in and make it super practical. First up, Azure API Management, APIM. Imagine you've got backend services, Azure Functions, App Service, Logic Apps, or even on-prem APIs, and you need a professional front door. That's APIM. You create an instance, developer tier for testing, standard premium for prod with VNet and scaling, then create and document APIs, import from OpenAPI spec, Swagger, drag your functions or web app definition, and APIM generates operations automatically. Add products, subscriptions, control who gets keys. The developer portal is built in, auto docs, try it console, code samples in multiple languages. Clients love self-service .now policies, the real power. XML-based, apply at global, product, API, or operation level. Rate limit, e.g. 100 calls min per subscription, quota, JWT validation, plugin enter ID, IP allow list, header transforms, mock responses, caching, tons. Exam scenario, protect public function endpoints from abuse, APM with JWT policy and throttling. Hands-on, provision APM, import a HTTP triggered function as backend, add JWT validation policy using your enter ID app, test in developer portal. Boom, secure, managed API. Moving to event-based solutions. Event grid first, lightweight, reactive pub sub. Create topics or domains for multi-tenant, sources, Azure services, blob created, resource manager events, or custom via HTTP post. Subscribers, functions, event hubs, webhooks, logic apps. Routing with filters, subject, event type. Retries exponential dead letter for failures. Use cases, react to storage changes, notify on resource creation. Event hubs for big data streaming, millions events sec. Namespaces, hubs with partitions for parallelism, consumer groups. Capture to blob data lake. Process with functions, event hub trigger, stream analytics, spark difference, grid for discrete events, this happened, hubs for continuous high volume streams, telemetry. Now message-based, service bus, enterprise reliability. Queues for 1.1, topics, subscriptions for pub sub, features. Sessions, ordering per key, duplicate detection, dead letter queues, transactions, peak lock. Premium for zones, GeoDR queue storage, simple cheap queues and storage accounts. Basic FIFO, great for decoupling without fancy features. When to pick, need guaranteed delivery, ordering exactly once. Service bus, high throughput ingestion, event hubs, reactive notifications, event grid. Basic background jobs, queue storage, best practices across all. Make consumers idempotent, safe to process twice, handle poison messages, scale out, monitor with app insights, hands-on gold. Upload blob event grid topic, triggers function processes, sends message to service bus queue. Another function consumes, saves to Cosmos. Front it with APM for external calls. We've covered the entire AZ-204 blueprint. You're ready to build, practice mocks, and pass. Drop a comment, APIM policies or event grid, which tripped you up first. Love your thoughts. Smash like if this series helped, subscribe for more cert guides, and go get that certification. You've absolutely got this. Boost your AZ-204 exam readiness with our comprehensive Azure Developer Associate practice test. Click the link in the description to challenge yourself with real exam-style questions, sharpen your skills, and confidently pass the certification. Don't just study, practice to succeed.